So the all points, the sum of the distance from two fixed points called foci is constant. So these are two foci, and the sum of the distance to any point on the ellipse from one foci plus the distance from the other foci is constant.
So wait, what's the foci?
So the foci, these are points on the um, on the major axis today. So these are points on the major axis, and right, which is the longer axis, and they lie on the major axis. And ellipse is defined by, for any point on the ellipse, the distance from a focus to one point to the focus on another point. Add the two, and it will be constant for every single point. So let's look at the horizontal and vertical orientations. The center is HK. The focus is H plus or minus CK. The major axis is 2A. The minor axis is 2B. The Pythagorean relation is C squared equals A squared minus B squared. Same thing for the vertical ellipse. So one way to think about the ellipse is it's a circle which has a horizontal radius and a vertical radius. And this is not mathematically correct, but it helps me think about it, is that for the horizontal orientation, the horizontal radius is longer. And for the vertical orientation, the vertical radius is longer.
Wait, repeat that.
So for the horizontal orientation, the horizontal radius is longer. And for the vertical orientation, the vertical radius is longer. So, and one trick while looking at this is to think, if this distance is 2A, and that distance is from the farthest end here, this vertice, to this vertice, what's this distance right here, which is half of that? If this distance is 2A, right, that's from this vertice to this vertice, what's this halfway length? Well, half of 2A, that's be 1A, right? And if this distance is 2B, half of that will just be B. So that distance is B, and this distance is A. All right. The major axis is called 2A, right? So, like I said, the major axis, that's the longest diameter of the circle if we're using this analogy. And the minor axis, 2B, that's the smaller diameter. All right. A.
Can you explain small?
Yeah, sure. So I want you to see this horizontal length. This length is longer than this vertical length, right? So if we're thinking about a circle, the analogy is the horizontal axis is the horizontal diameter, and the vertical axis is the vertical diameter. And that the horizontal axis is longer. That's what's the major axis. If we're vertical, then the vertical axis is the longer one. A indicates the semi-major axis. So this is the semi-major axis, and B is the semi-minor axis. So A is the semi-major axis. Semi-major axis. And B is the semi-minor axis. That's the same thing for the vertical orientation. All right, you also have vertices. So if your center is HK, what do you think would be the value of this vertice right here? What do you think would be the x value? Yeah. Well, assume so this is a little bit abstract. If the x value is 8, right? The x value here is the same x value as the center. So the x, so right here, this for this vertice, the x value is still h, but now it's k, because the y value is k, plus 1a. So it's k plus a. And here the vertice is hk minus a. Okay, so can we get that h is the x coordinate of the center and k is the y coordinate of the center? And then this length is 2a, which means half this length is a and half this length is a. If the at these 2 points right here, the x coordinate stays the same. So the x coordinate is going to stay as h. But now the y coordinate, for this point, the y coordinate goes up by a. For this point, the y coordinate goes down by a. So this y coordinate is hk plus a. This coordinate is hk minus a. All right.
Pardon the interruption, staff. All teachers participating in senior exits. All teachers participating in senior exits. Please make your way to your assigned station or room. All teachers participating in senior exits, please make your way to your assigned rooms at this time. We want to get started as soon as possible.
All right. So, and what do you think would be the coordinates for these points? Or does the y value change from the center?
No.
So that stays as k.
So would that be h plus a?
Well, now instead of adjusting by a, we're adjusting now by b. So that would be, what would this be? H. So what? Yeah, h what? Plus or minus? H plus bk. And this point would be h minus bk. Okay. And just look at, we express this ellipse in in this form, x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So hk is our center. So we switch the signs from our equation, and we find the square root of a squared to find a, and the square root of b squared to find b. All right, and this is our Pythagorean relation, how we find c. C is our focus. So let's C. We'll see. Yeah, C is our focal length. So C is the focal length. That's the focal length. All right. Let's are we do you want some more time on the slide? Do you want to move on? And there's it's a lot to write, but you can maybe write some of the stuff in the margins because I know there's more space in the margins. Okay. So let's label the parts of the ellipse. We have a co-vertex, the major axis, the vertex, the foci, the co-vertex, the minor axis, and the vertex. So the two vertex are called vertices. The co-vertex, that's called co-vertices. And you have the center and the foci. So the center is HK.
Wait. So okay.
So the center is HK. This vertex right here is now going to be H plus A, comma, K. Here's why. This is a horizontal ellipse because the longer axis is horizontal. A is always going to be the length of the semi-major axis, which is the longer axis on the ellipse. So this is vertex is H plus A, comma, K. This axis is h minus a, comma, k. And that's part of the major axis. The major axis has a length of 2a. The minor axis has a length of 2b. Our covertex is going to be h, k plus b for this covertex, and h, comma, k minus b for the lower covertex. For our foci, this foci is going to have a value of h minus c, comma, k, and this foci will have a value of h plus c, comma, k. And this is because our focus is a focal length of c away from the center. All right. Any questions or concerns on? All right, let's get to the practice problem. All right, an ellipse. And you notice you have a minus sign on your page, so turn that into a plus sign. All right. Now, we look at the orientation. First, we look at the orientation, and we ask ourselves, what denominator is larger, the 36 or the 9? 36, and is 36 under the x term or the y term? An x term, and does x indicate horizontal or vertical? Horizontal. So our orientation is a horizontal ellipse. All right, now the center. For our center, the x coordinate of the center, the h coordinate goes with the x term, and the y coordinate of the center goes with the y term, but we just switch the signs. So -3, flip the sign. What's x coordinate of the center? 3. And 3, -1. That's the center. Now the foci, to find the foci, we have to calculate a lot of things. First, we have to calculate a squared and b squared. A squared is always going to be equal to the larger denominator, and b squared is always going to be equal to the smaller denominator. So a squared is equal to 36. What is a equal to? If a squared is 36, what's a going to be equal to? 6, very good. And if b squared is going to be equal to 9, what's b equal to? 3. Excellent. Now, when you use our Pythagorean relation, and our Pythagorean relation for an ellipse is that a squared is equal to b squared plus c squared. That's the Pythagorean relation for an ellipse. So c squared is equal to a squared minus b squared, which means c squared, or c, is equal to the square root of a squared minus b squared. Okay? And this would mean c is equal to the square root of a squared, which is 36, minus 9, which is b squared. So that's 36 minus 9, that's 27, right? So c is equal to the square root of 27, and the square root of 27 I can rewrite as the square root of 9 times 3. What's the square root of 9? 3. So I can take out that 9, that's a 3. That becomes 3 root 3. Now, you have your foci, and you have C, and you have your foci. Does the foci land on your horizontal, on the major axis? And here the major axis is horizontal because it's a horizontal ellipse. So our foci are going to be, once we found C, because we found C is 3 root 3. Our foci are going to be the x coordinate of the center, 3 plus or minus 3 root 3, comma, negative 1. Our vertices are going to be, well, what do we determine our A term is? 6, right? So vertices are going to be 3 plus or minus 6, comma, negative 1. And the reason why the vertices are 3 plus or minus 6, negative 1, is that the vertices land on the horizontal major axis. They land on the horizontal major axis, and the co-vertices land on the minor axis. So what's our B? Our B value is 3. Our co-vertices are going to be 3, negative 1, plus or minus 3. All right. So we actually have two foci. 3 plus 3 root 3, negative 1, that's one foci. And 3 minus 3 root 3, that's negative 1, that's other foci. We have two vertices. 3 plus 6, which is 9, negative 1. And 3 minus 6, which is negative 3, negative 1. And two co-vertices. 3, negative 1 plus 3, which is 3, 2. And 3, negative 1 minus 3, which is 3, negative 4. The length of a major axis, if A is 6, 2A is equal to 2 times 6, which is 12. And if B is 3, minor axis is 2B, which is 2 times 3, which is 6. So this would be 9, negative 1, and negative 3, negative 1. And this would be 3, 2, and 3, negative 4. Oh, sorry. Let me get you a chance to write things down. You got it? Oh, excellent. Keep it quick. All right. So this one's a little bit trickier. All right. Here we're going to have to complete the square in order to get it into a form where we can analyze it. So this is going to be our first step is to group our x squared and x and y terms, and then we're going to have to factor out any coefficients for the x term.
Wait, do we set them equal to each other?
So, well, before we do any of that, I want to group my x and y terms, and then get my constant on the other side of the equal sign. So I will have 4x squared minus 24x plus y squared plus 4y equals negative 24. Okay? Then, for my x term, so all I did here is I grouped my x's and the y's, and I moved the 24 over to the other side. So I got my constant on the other side. Then, my next step is to factor out the 4 so that my x squared doesn't have a coefficient. So now I have 4 times x squared, what's 24 divided by negative 24? Yeah. Sorry. X squared minus 6x plus y squared plus 4y is equal to negative 24. And this is where I need to complete the square. And I don't think did you miss to complete the square lesson?
No.
Oh no, okay. So let's complete the square for x squared minus 6x. How do we complete the square for x squared minus 6x? We take that negative 6, and what's our first step? Well, first we'd have to divide by. So we need to complete the square. So it's just a process. We need to essentially we're adding numbers to both sides of the equal sign to make our terms perfect squares so that we can factor them. So this is -6 divided by 2. So first step, you take your coefficient of x. In this case, that coefficient is -6. You divide it by 2. That becomes -3. You square -3. That becomes 9. -3 times -3 is positive 9. Then I take 4 divided by 2 is equal to 2. 2 squared is 4.
Because like,
Yeah.
the reason why I asked about choose dividing 6 by both sides, I was just like, wait, why? But
Yeah.
now,
Yeah, so I'm not even doing anything this step. I'm doing a separate calculation almost off to the side. Now that I know that I have that 9, I have 4 times x squared minus 6x plus 9 plus y squared plus 4y plus 4, all right? And that's going to be equal to -24. But anything I add to the left-hand side of the equation, I have to add to the right-hand side. So one thing I've added to the right-hand side is a 4, right? So I have to add 4 to each of the side. And this next step is a little bit tricky. I added a 9 here. But this 9 is being multiplied by a 4. So I've added a 9 times 4 to the left-hand side. So I have to add a 9 times 4 to the right-hand side as well. 9 times 4. So now I can factor my x terms and y terms and simplify my equation on the left and right. So x squared minus 6x plus 9 will factor into x, because it's an x term, 4 times x minus 3 squared plus y, it's a y term, so y plus 2, that's a positive 2 right there, squared is equal to -24 plus 4 is -20. 9 times 4 is 36. -20 plus 36 is 16. So it's equal to 16. Lastly, the standard form ellipse has a 1 on the right-hand side of the equal sign. So we're going to get a 1 on the right-hand side of the equal sign. I'm going to divide each side by 16. Four sixteenths simplifies to 1/4, because 16 divided by 4 is 4. 4 divided by 4 is 1. So I can get x minus 3 squared over 4 plus y plus 2 squared over 16 is equal to 1. And I finally have simplified the standard form of my ellipse. And from this equation, I can now better find key features about the ellipse. Now, a squared is always a larger denominator. So a squared is equal to 16, which means the square root of a is equal to 4, because the square root of 16 is 4. And b squared is equal to 4, which means b is equal to 2. And c is equal to the square root of a squared minus b squared. So c is equal to the square root of 16 minus 4. So it's equal to the square root of 12. And 12 is 4 times 3. The square root of 4 is 2. So that's equal to 2 root 3. Because if you have 4 times, if you break down 12 into 4 times 3, the square root of 4 is 2. So you can break that 2 outside. But this root 3 has to stay in there. So now After all of that, we can answer this information. The orientation. Vertical, excellent. All right. The center. What's the x-coordinate in the center?
4.
Mm-hmm.
-4.
Let's look at our equation.
3.
3, and the y-coordinate of our center. -2, excellent. And the foci, remember this is a vertical ellipse now, and c is equal to 2√3. So what's the x-coordinate of the foci? So now the foci land on the major. So if I'm drawing a vertical ellipse, right? I have a center. This is my major axis. My foci land on my major axis. Okay, so this is my center. These are my foci. Co-vertices and vertices. Notice the foci are on the major axis, and they're away from the center by c. So for my foci, F1 and F2, does the x-coordinate of the foci change from the x-coordinate of the center? Well, I mean, look, this is the center. These are the foci.
No, it doesn't.
Doesn't change. So the x-coordinate of the center is, yep. So yep. And now we have to find the 2 coordinates of the foci. Remember, the foci is c units up and down from the y coordinate of the center for a vertical ellipse.
So it would be -2 ±
Yes, -2 plus or minus.
2.
Excellent, 2√3. That's absolutely correct. All right. How are the vertices?
So would it be 3, -2?
Yeah. So you have 3, -2 plus or minus. What's A?
A is
4. So plus or minus 4. And our co-vertices. Now the co-vertices are changing horizontally.
so would it be 3, you said horizontal.
Yeah, the plus or minus 2, good, comma, -2, excellent. And if A is 4, what's the length of our major axis? Remember, our major axis is 2A. If A is 4, what's 2A? Yep. And if our minor axis is B, so that's going to be, so minor axis is 2B. So if B is 2, 2B is going to be 4. Excellent. That's all our key features. I mean, that's it's why it's important. I mean, it's tough if you miss notes. Okay. But wait, were there anything you had to get down there?
Oh, yeah, I was just
Okay.
like, what's
Yeah.
the name?
Cool. All right. Let's go to this problem. Now we have to group our x's and y's again, get the constant on the other side. So we have 9y squared. So I'm gonna get it all on one side. We'll have 9y squared plus 72y plus 4x squared minus 48x is equal to -144. And I'm going to factor out a 9 for the y terms and a 4 for the x terms. When I factor out my 9, what's left over is y squared plus 9 times what is 72? Yep, so 72 divided by 9 is 8. Y squared plus 8y. Okay, and I'm going to have my complete the square term.
That's going to be plus 4 squared is 16.
Excellent. You're doing some mental math. You're ahead of the game. And then we factor out that 4 plus 4 times x squared. And what's 48 divided by 4? All right, what's 48 divided by 2? Yeah, 12. So it's going to be x squared minus 12. All right, plus our complete the square. Oh, yeah. So that's sorry. This is a complete the square term for the y's, plus a complete the square term for the x's, and that's going to be equal to 144. I'm sorry, this is going to be cramped. Plus our complete the square term for the x and our complete the square term for the y. So to find our plus our complete the square term for the x and our complete the square term for the y. So I'll use this space to show that 8 divided by 2 is 4, and 4 squared is 16. So complete the square term for the y is 16. So that's 16 right there. A little bit hard for you guys to see. But that's 16. And for this one, it's negative 12 divided by 2 is 6. Sorry, negative 12 divided by 2 is negative 6. And negative 6 squared is 36. Negative 6 times negative 6 is positive 36. So that value is 36. And it's hard for you guys to see, but listen to my voice. And so we have 9 times y squared plus 8y plus 16. This is going to factor into y, that's a positive 4, plus 4 squared. All right, plus 4 times x minus 6 squared is equal to negative 144 plus the coefficient of our x term was 4, so it's going to be plus 4 times 36. That's like a complete square term for the x. Plus our coefficient for the y term was 9. That's 9 times 16. And so now I have 9 times y plus 4 squared plus 4 times x minus 6 squared is equal to, and we have to do in our calculator, 140. Yeah, so if we do, yeah, negative 144 plus 4 times 36 plus 9 times 16, that's going to give us 144. So that's equal to 144. Now we have to divide each side by 144 so that we have a 1 at the end of dividing. So we divide each side by 144. We have a 1 left over on the right-hand side. We can use a calculator to find out what 4 over 144 simplifies to. So 4 divided by 144
afternoon, Olympic High School. Quick announcement, all judges who are grading senior exits, you need to keep your red folders in the room. The only thing that you're going to give the hall monitors are binders. Again, keep the red folders in the room, give the hall monitors the binders. Also, Miss Harvey, can you please come to my office? Thank you.
Okay, so 4 over 144 is 1/36. So this will simplify to x minus 6 squared over 36. And 9 over 144 is going to be, convert that to a fraction, math, frac, 1/16. So that will be y plus 4 squared over 16. Y plus 4 squared
So basically, it's
over 16.
it's the when you did 8 divided by 2 is 4 plus 7 is 16. It's basically that over.
Well, yeah, so when I added this, my first step of completing the square, I always add that term to my y or x term to find what my perfect square is. And now what we can see is that, first of all, is the denominator larger under the x term or the y term? X term. So our orientation is horizontal. So the horizontal orientation. And for our center, what's the x coordinate of the center? 6, and the y coordinate of the center? -4. Excellent. And if 16 is equal to a squared, and so I have a little bit less space to work here, so I'm going to just do it at the bottom. If 16 equals a squared, what does a equal? 4. Well, oh, I'm sorry. I messed up here. Forget that. A squared is always the larger denominator. So sorry for making a mistake there. 36 is equal to a squared, and a is equal to 6. 16 is equal to b squared, it's a smaller denominator, and b is equal to 4. C is equal to the square root of 36 minus 16. 36 minus 16 is 20, so C is equal to the square root of 20. Okay? And 20 can be written as 4 times 5. The square root of 4 is 2, so that's going to be equal to 2 root 5. 2 root 5. The foci of an ellipse, remember this is horizontal, so if C is 2 root 5, what are the foci of this ellipse? Of a horizontal ellipse?
So it's going to be
6 plus or minus 2 root 5, comma, -4. So those are our two foci, 6 plus 2 root 5 and 6 minus 2 root 5. Our vertices are going to be, what's our A term? 6, so it's going to be 6 plus or minus 6, as A is 6, -4. Our co-vertices, B is 4, so that's going to be 6, -4, plus or minus 4. The length of our major axis, which is 2A, that's going to be equal to, 2A is 12, right? 2 times 6 is 12, and our minor axis is 2B, 2 times 4 is 8. All right? So that's, it's a long, complicated process, but if you can break it down to standard form, you can find A, B, and C using the Pythagorean relation, and then find the key features of the ellipse. Okay.
Vertices and co-vertices?
Yeah, sure.
What is that?
So for vertices, so this is a horizontal ellipse.
Mhm.
The vertices are the endpoints at the end of the major axis. So we have, this is the center, right? HK. We have a vertice right here. So that's H plus A, comma K. And the other vertice is, that length is also A, H minus A, comma K. That's why my vertices are 6 plus A, comma K, H plus A, comma K, H minus A, comma K. 6H plus 6A, comma K, negative 4. 6H minus A, 6, comma negative 4K. And for covertices, same thing. The covertices are above and below the center, and that's by a value of B. HK plus B, HK minus B. Another trick is to graph things in Desmos. Okay. So let's look at this situation right here. Major axis endpoints at negative 3, 2, and 5, 2. Minor axis endpoints at 1, negative 1, and 1, 5. So notice what changes here. What coordinate changes for the major axis endpoints, x or y? Well, for major axis endpoints, does the x coordinate change and the y coordinate stay the same, or does the y coordinate change and the x coordinate stay the same? For a major axis endpoint,
Oh,
the x coordinate changes. So if we draw our ellipse, because the x coordinate changes, we know this is a horizontal ellipse. Actually, before I draw that, I'm just going to try to draw this ellipse a little bit better. All right, so I have major axis endpoints at 5, 2 and negative 3, 2. All right, and then I have minor axis endpoints at 1, negative 1 and 1, 5. So this point right here is 1, 5, and this point right here is 1, negative 1. What are, just from looking at this, can you find out what's the x coordinate of the center?
the x coordinate?
Yeah, of the center. 1. What's the y coordinate of the center? 2. Excellent. So we know the center is 1, 2. What is the length of our major axis? Well, yes, because we go from negative 3 all the way to 5. So 2a is 5 minus negative 3, which is 5 plus 3, which is going to be equal to 8. And then if 2a is 8, that means a is equal to 4. And then 2b, so that's 2a, this is 2b, that will be 5 minus negative 1, which is 6, because the distance from negative 1 to 5 is 6. So if 2b is 6, then b is equal to 3. Now, we can write our ellipse in standard form. Let's look at the x coordinate. The center is 1, right? So it'll be x minus 1 squared, that's the x coordinate of the center. And because this is a horizontal ellipse, that means that a squared goes under the x term. So if a is 4, what's a squared? Yep, over 16, which is a squared, plus y minus 2, the y coordinate of the center is 2, squared, over b is 3, so b squared is 9, that's b squared, is equal to 1. And that is the standard form of this ellipse.
I guess like when you are really focused and pay attention, it makes more sense.
Yeah, maybe that's one tell class to focus. Okay? Focus, pay attention. All right. Now this one's a little trickier, but it's doable. So our foci are at 19.3 and negative 7.3. So once again, do we see that the foci, they're moving along the horizontally? All right, so now we once again have an ellipse with a horizontal major axis. All right. Our foci are at 19.3 and negative 7.3. So I have a foci at this point, 19.3, and negative 7.3. Negative 7.3. I've also indicated that my major axis length (2a) is equal to 30. What is, you may not, so I didn't tell you explicitly, so it's okay if you don't know. But what do you think our focal length is?
Okay.
So the focal length, well, I'll tell you the definition. Let's see if we can find out. The focal length is the distance between the center and the focus. That's C. So if the distance between the center and the focus is C, what do you think the distance is between the two focuses? Well, that is 26, but if the distance between the center and one focus is C, in terms of C, what's the distance between both focuses?
13.
Well, yeah, so C is 13, but what I'm trying to get at is that if the distance between the center and the focus is C, the distance between two focuses is 2C. Because it's C to get from one focus to the center, and C to get from the other focus to the center. So 2A is equal to 30, and 19 minus 7, or 19 minus negative 7, that's going to be equal to 26. So 26 is equal to 2C. So 2A is equal to 30, A is equal to 15, and if 2C is equal to 26, C is equal to 13. I also need to be able to find, if C is equal to 13, what's the x coordinate of the center? Yeah, let's think about the x coordinate of the center here. Well, what's this? The x coordinate of this focus is 19. So this focus is at 19.3. The center is 13 away from 19.3. So it's 19 minus 13. Yeah, so we have 6, and the y coordinate still is 3. So 6, 3 is our center. So we have a center at 6, 3. HK, that's 6, 3. And also just 6 is the halfway point between 19 and negative 7. and the focus is always, if you have two foci, the center is the halfway point in between them. So now we can use our Pythagorean relation. A squared minus B squared equals C squared. A squared. So with ellipse, it's A squared is equal to B squared plus C squared. We're solving for B. So B is equal to the square root of A squared minus C squared. So B is equal to the square root of 15 squared minus 13 squared. And let's do the square root of 15 squared minus 13 squared. The square root of 15 squared minus 13 squared, that's going to be 7.483. So B is equal to 7.483 approximately equal to 7.49. But B squared, which is what's important, this value squared is equal to about 56. Oh, so B squared is 56. So B squared is 56. And A squared, if A is 15, A squared is equal to 15 squared, which is, should be 225, I believe. Yep, 225. That's equal to 225. Now, we can write our ellipse standard equation. X, 6, 3 is our center. X minus 6 squared over A squared, which is 225, plus Y minus 3 squared over B squared, which is 56, is equal to 1. All right. So the last part is the eccentricity of an ellipse. The eccentricity of an ellipse is C over A, and that's how circular or stretched an ellipse is, okay? So the eccentricity is C over A, so try working and solving for C. So 36, what's 36 equal to? Just in terms of A, B, or C.
36 is going to equal A.
Well, not just A, but not just 2A. Well, it's not 2A. What's 36 is A squared. 9 is B squared because it's the smaller one. So that means A is equal to 6 is equal to A, 3 is equal to B, and now we need to find C. And C, using our standard, is going to be equal to, for an ellipse, the square root of A squared minus B squared. So it's going to be the square root of 36 minus 9. What's 36 minus 9? Right, so C is equal to the square root of 27, right? And the square root of 27, that's the square root of 9 times 3. The square root of 9 is 3, so I can take the 3 out. That's equal to 3 root 3. So C over A, our eccentricity is equal to C over A, which is equal to C, which is 3 root 3, over A, which is 6, and 3 root 3 over 6, 3 root 3 over 6 is 0.866. So that's going to be equal to 0.866, and 3 root 3 over 6 will also simplify to root 3 over 2. So 0.866, that's root 3 over 2. And now that's the entire ellipsis notes.